Okay, so this video is going to go over graphs. So in graphs, you have part-to-part ratios and part-to-whole ratios. And so ratios are something that we've learned about before. Basically, if you think of a part-to-whole ratio, that's basically like a fraction. Okay, and then when you get to middle school, you start learning about how there's different kinds of ratios, and there's also part-to-part ratios. And so what we're going to look at is we're going to look at part-to-part, part-to-whole ratios within graphs. So we're going to start with what we call a dot plot. So if you look at this dot plot, it represents family size and number of children in a family. And if you think of each of these dots as representing one piece of data, then you can see that 3 people said there's 1 child in their family. And so if I were you, I would write that number on top. Just like a bar graph, it's a good idea. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 1, 2, 3. Okay, so once you do that, it becomes very easy to answer any questions that we might look at for part-to-part, part-to-whole. So each of these are a part. Okay, so I'm going to label all the parts today in blue, and I'm going to label all the wholes today in pink. So think about how you would find the total or the whole amount here. Okay, a lot of students will want to add these numbers. But what do those numbers represent? They represent the number of children in the family, not the total number of people that voted. So what you would do is you would add up all these numbers together to figure out how many people or how many pieces of data you have. So if you add these together, let's see, that would be 20, 23, 25, 26, 27, 28. Okay? And so once you know that, you can answer any questions. For example, if I were to say what ratio represents the number of families with 1 children in their family compared to the number of families that have 3 children in their family. And so you would look here, and there's 3 families that have 1 child and 12 families that have 3 children. And so a part-to-part ratio here could be 3 to 12. And remember, you can write a ratio in verbal form, with colon form, or as a fraction. And it is a good idea to always simplify. And so you could say this is 1 to 4, 1 to 4, or 1 to 4. So you read it the same way, but you can write it 3 different ways. Okay, another thing you could say is what is the part-to-whole relationship between the number of families that have 4 children and the total. So you could just say, okay, well here would be, bless me, sorry, this would be 2 out of 28. So this is the number that have 3 children, and this is your total. And then, of course, you would simplify, and that would simplify to 1/14. Okay? The other way we can ask, and I'm going to do this in orange so you can kind of see it, is how many more families have, let's say, 4 or more children than families that have 2 or less children. And so what you would do here is you're comparing 4 or more, 2 or less. So 4 or more would include anything in these sections, right? 4 or more. So it includes 4. So we could see easily here that there are 5 families that fit into that category. 1, 2, 3, 4, 5. Okay, 2 or less, you can count 1, 2, 3, 4, 5, 6, 7, 8, or use your numbers. 8 plus 3 will give you 11 fit in that category of 2 or less. So how many more students will say how many more families have 1 or 2 children in their family and have 4 or more? You could just do 11 minus 5 and get 6. Okay, so really dot plots, you just need to understand how they work, and I think the main key is to write these guys right here to help with all this math, and also to recognize that unless it says otherwise, each dot represents 1 piece of data, or you could think of like 1 vote. So if you were to do shoe size like we did in class, you would come up and everybody would get to put 1 dot on the board. So each of these represents a vote. These numbers don't represent the votes. These numbers represent what they voted on. For example, the number of children in a family or shoe size. And so that's kind of dot plots. You do the same thing with bar graphs. I know you've been dealing with bar graphs for a long time. Same strategy. You want to write the number on top and be very careful, because if you see here, it's in a different interval, which I know y'all learn a lot about that in science. So you can kind of see, it's a 7 and 4. And once you write the numbers up there, you can do the same kind of things. You can find the total or the whole by adding all these numbers together. This is the number of times each week that a teenager is reminded to do chores. Okay, so you can look here, the number of reminders. 2 people had to have 0 reminders. 14 people or teenagers had to have 3 reminders. Okay, so you do the same thing. Notice the similarities between dot plots and bar graph. Okay, the next one we're going to kind of look at are circle graphs, and these are kind of, when you see circle graphs, you really see percent a lot. Circle graphs are excellent at comparing part to whole. Okay, comparing part to part can be a little bit tricky, but you can definitely do it. Now, in order to do that, it has to tell you, so we have percents right here, but we need to know how many total people were polled. So for the purpose of this, we're going to say 200 people were asked, and it'll almost always tell you right before the graph in that paragraph. 200 people were asked what their favorite movie is, and so from that, if I know, and I'm going to write that in pink because that's actually the whole or total. If I know 200 people were asked, and these are the percentages, that is enough information to figure out exactly how many people liked comedy out of those 200. Because keep in mind, this is not 50 people. This is 50%, or 50 out of every 100. 50% per 100. Okay? So in order to do that, we're going to use proportions. Imagine that. Okay? So this is your proportion. You have, if you remember, your part over whole or total equals percent, and percent is always over 100. If you memorize that percent proportion, this becomes very, very easy. So if you look here, the total is always going to be 200. Let's say we want to know how many people voted for comedy. Now, you could probably do this in your head. 50% is half. So half of 200 people, we know the answer is going to be 100. But I'm going to prove it with a proportion, and then when we get to, we'll do this 13% next. Bet you can't do that one in your head. Okay, so our part, we don't know the part. We don't know the actual number of students that voted for comedy, but we know that it was 50 out of 100. I'll just do that in blue because that is a part. Okay, so then you solve your proportion. You can do cross products, 50 times 200, or there's a really easy shortcut here. How you learned in 6th grade is your rate of change. So you can divide both by 2. But if you look, your variable's over here. So we want to kind of go in the direction of our variable. So to go from 100 over to 200, we want to go from right to left because our variable's over here. We are multiplying 100 times 2 to get 200. So I would do 50 times 2 to get x, which is, in fact, 100. So what I would do is I would write 100 people in this little section so that I don't forget that section is 100 people. Okay? Then you can go through and do the rest of them. I will tell you, if you want to pause this video and try it on your own, you are welcome to. For action, I'll tell you that that is going to be 50 people. If you don't believe me, try the proportion. And then let's do drama. Let's see how many people like drama. So I can't do that one in my head. 13% is not, it's kind of an ugly percent. So we don't know how many people, but we know it's still out of 200. We know that it's 13% out of 100 because it's 13%. Okay? So again, you can do cross products, but I'm going to work smarter, not harder here. I'm going to go in the direction of the variable. Since my variable's over here, 100 times 2 will give me 200. So if I multiply the bottom by 2, I have to multiply the top by 2, and I get x is 26. So 26 people liked drama. Whoops. Okay? And so basically just really understanding percent will help you answer those questions. Okay, the last kind of graph we're going to talk about is a box plot. Okay? It's just another way to represent data. If you look here, these are labeled for you. This is a gift. This will not always happen. So you have your minimum or your lower extreme, your maximum or your upper extreme, quartile 1, quartile 3, and then perhaps the most important part of a box plot is the median. Not to be confused with the mean. A way you can kind of remember it is there's a line right here. Think about like in the middle of a road, if you travel on a highway, they call that the median when it's right in the middle of the highway. Like if you're driving on 1604, there's those cement walls in between the two directions of traffic. That little section of grass in the middle, right in the middle of the road, is called the median. And in math, we also call that right in the middle, that middle number, the median. Now notice this line, this median, you have to read it. We're going to say that that is 35. And so a good idea would be to write all these numbers. So this is 35. This is 44. I hope you're noticing a trend. I'm going to estimate that to be 54. That when we do graphs, we write the numbers as much as we possibly can. Okay, so now I can ask you things like, what is the range? Well, range is from this minimum to the maximum, the difference between those. So to find the range, I would do 54 minus 13. Okay? If I ask what the median is, we already wrote it down. Yay, it's 35. Now remember, median is right in the middle of your data. So you know that half of your data, whatever it is on this side of the median. Half of your data, whatever it is on this side of the median. Okay? And so 50% is down here, 50% is up here. All right? For quartile 1, that's kind of like your first quarter. So you can think of this as the lower quarter is in between here, the upper quarter is in between here. And so what box plots allow you to do is kind of see where's the center of the data, where is it all gathered around. And median is a really good indicator of where the center of the data is. So if you look at the temperature in this example, the median temperature was 35 degrees. We are not used to that in San Antonio, but that's the median for this data. Okay, so that concludes our videos on graphs. My biggest hint to you would be to write the numbers right on top, and it becomes answering these questions very easy. Graphs are a lot about reading. If you don't notice on circle graphs that it says 200 people, it's very difficult to get that one right. Okay, so take some practice with it, and I hope you enjoyed.